Your AI agent can take over your machine. This isn't hyperbole, it's the fundamental security risk of giving a powerful, undirected model access to your operational environment. When an LLM is granted agency, the ability to execute actions based on its output, it becomes a vector. It might not be malicious, but if it's flawed or prompted incorrectly, its unbounded capabilities map directly to your system's vulnerabilities. The transition from cool prototype to reliable product requires shifting your mindset. You are no longer just building a predictor, you are deploying an autonomous system with execution capabilities. To manage this leap in risk, we must move beyond prompt engineering and adopt strict architectural controls. Here are the 5 absolute limits you must enforce. Limit number 1, execution sandboxing. This is your absolute isolation layer. The agent should never run natively on the production host machine. Think of it as a low-level VM or containerized environment. If the agent breaks out, it's contained within a disposable, monitored shell that cannot reach critical resources. The sandboxed environment dictates what the agent can touch. It limits syscalls, restricts network access, and enforces resource quotas like CPU time or memory allocation. Limit number 2, bounded context execution. You must define the precise operational scope of your agent and refuse to allow it to drift into unrelated domains. If your agent is designed to manage tickets, it should not have the capability or permission structure to modify production code bases or delete databases. This principle of least privilege must be baked into the agent's identity and its runtime profile. It is a design choice, not an afterthought. Limit number 3, read-only interfaces and API gateways. Any interaction with external systems must pass through a heavily vetted, read-only choke point. Instead of letting the agent write directly to your production database, it submits intent through a middleware layer. This layer validates the action, checks business logic, and executes the transaction safely. This enforces a crucial separation. The agent decides what needs to happen, the gateway decides if it can happen, and how it must be done. And for high-risk actions, like financial transfers or deployment triggers, the action must be flagged and transitioned from execute to approve, requiring human confirmation. This slows down the loop, yes. But it is the indispensable friction needed between raw AI capability and critical system control. Limit number 4, the kill switch and human oversight loop. You need an emergency brake, and you need a continuous feedback mechanism. The kill switch isn't just a big red button. It means predictable, immediate cessation of all agent activity upon detection of anomalous behavior or drift. This requires constant health checks, not just on the LLM inference latency, but on the intent and action vectors it is generating. The oversight loop ensures that when the agent encounters ambiguity or enters a high-risk state, it doesn't guess, it escalates the decision back to a human operator. This hybrid human-AI pairing is the ultimate safety net. It balances scalability with accountability. Finally, limit number 5, auditability and observability. You must treat every action the agent takes, or proposes, as a tamper-proof record. The system must log not just the final action, but the entire chain of thought, the prompt received, the retrieved context, the weights applied, and the chosen action. This full transparency allows you to reconstruct the exact causality chain if something goes wrong. It turns a potential security incident into an engineering debug session. By enforcing these 5 architectural limits, sandboxing, bounded context, gateways, kill switches, and auditability, you are not slowing down AI, you are hardening it. Security and capability are not mutually exclusive. They are 2 sides of the same robust engineering equation. The future of reliable AI deployment depends entirely on whether we treat the agent as a smart brain or as a powerful, potentially rogue machine.